Hello everyone, my name is Josue Cortez and this presentation was created for Data 625 Data Visualization at the University of Maryland Global Campus. Climate change has been highly politicized, causing confusion and skepticism among people worldwide. Can we establish a relationship between greenhouse gas emissions and a rise in the sea level? What about total population and CO2 or sea level? In order to answer these questions, we need yearly measurements of all three variables. Luckily, the United Nations maintains such data. I sourced data from CO2 level measurements, sea level measurements, and world population over several decades. However, a direct year-to-year comparison can be achieved by looking at a time frame where all data sources overlap. We filter the data to evaluate only from the year 2000 through 2020. This data can be reasonably trusted as the United Nations is a reputable world organization. Let's take a look at my findings over the next few minutes. First, let's look at the sea level. As you can see, the average sea level measurements are somewhat erratic, going up some years and down others. A future forecast shows a steady level from the last year of available data to 2026. At 326,000. I believe that this erratic behavior causes the forecast to look like that, and this provides low confidence in the forecast. I added a trend line which helps understand the data a little better, showing a slow but steady rise. I have more confidence on the trend line than I do the forecast. Next, let's look at the world population. This data is much more stable, showing a steady growth year over year from just over 6 billion in 2000 to almost 8 billion in 2020. Using this data, we can forecast with high confidence that the world population will reach 8.2 billion people by the year 2026. Now, as you can see, the y-axis shows millions, not billions. This may be a little confusing, but the reason is that the value is measured in the thousands unit. Therefore, 1 million equals 1 billion. Next, let's look at the CO2 levels. This data is also well presented, and while it goes up and down, there is no need for a trend line to identify that it has a downward trajectory. While the CO2 levels were showing a steady increase through 2007, you can see a significant slump from 2007 to 2009. It is possible that the housing market crash of 2008 and 2009 is responsible for that deep valley. In 2010, you see a spike and then a steady decrease, until in 2020, it drops again significantly. Once again, a worldwide event halting travel and human activity, the COVID-19 pandemic, may be the culprit, because there are significant worldwide events that may have an effect on this data, which could be considered outliers. I give the forecast, which indicates the lowest levels in 25 years, a medium level of confidence. The next visualization was created in an attempt to find a correlation between CO2 and sea levels. As you can see, the trend lines show an inverse relationship, which is somewhat unexpected. Sea levels appear to be rising, but CO2 parts per million as measured across the globe may have little to no impact on it. Now, as a data analyst, I'm not a climate scientist. The volume of CO2 in the atmosphere could have a severely delayed effect, and 20 years of data may not be sufficient for establishing a relationship between these two variables. And finally, let's take a look at all the variables together. We can see that population and sea levels trend together in an upward trajectory. CO2, on the other hand, has a downward trajectory. However, correlation does not quite equal causation. Therefore, we cannot establish that the rise in world population has any effect on the sea levels or CO2. The facts are simple. Population and sea level are rising, and CO2 is in decline, even as more people walk the surface of the earth. Maybe some kudos are due to the climate activists, whether CO2 is or not the reason for rising sea levels. This concludes my presentation. Thank you for your time.